Hello, Lexi, and welcome to your Tp2 homework recap read-through. This is homework 4. So the contents of this homework: divergence, surface integral, and a very simple volume integral. Divergence, I'm not even going to get into it. Surface integral, so it's like this. It's your vector field times your little vector ds. Now, ds can then be broken up into your normal unit vector times a scalar ds, because scalar times a vector will give you a vector. The normal is just something that is like perpendicular to the surface. So now you have a little surface element ds, and to find the vector, you just multiply it by this normal unit vector n. Now this ds can then be broken up into a Jacobian and a dA. dA like is just your little like d phi, d theta, dr, d whatever. And the Jacobian kind of just like, if it's a curved surface, not all ds's are going to be equal in size, so that dA will kind of just account for that. Not dA, sorry, the Jacobian. So you can rewrite it and get it in the form of this: E times n vector times d whatever. This can also be written as like the unit vector times the modulus. It's just the same thing. This n vector, normal vector n. Examples of Jacobians that you will sort of like all you will really use: cylinder is r, and a sphere is r squared sine theta. Tips: see an x or y that makes integration bad, summon the x and y component from R of whatever system you're in. Simple as, if you have an R that is cos phi sine phi 0 or something, and you have, for example, you're integrating like x plus y, you can just sub in cos phi for x, sine phi for y, and if you're integrating over phi, then that's going to be simple. You don't have to, because if you have other variables in there, it's going to be complicated. What you want is to be integrating over two variables if you're doing a surface integral. And just for your knowledge, when you're finding a Jacobian, it looks like this. It's the modulus of the cross product between the two derivatives of your position vector. In this case, it's a cylinder. So it's dr d phi cross dr dz, and you'll see we end up with r, which is what we said earlier. And now a volume integral. This one was super simple. It was just find the volume of a sphere, which is you just dv equals volume, where dv is your scalar dv. So you have the Jacobian times your little integration elements, and you get the volume of a sphere. That's it for now. Goodbye.